electricity, we have a chapter, and that chapter tells us about the combination of resistance. Means resistance means something that opposes the direction of current, and the previous topics, what is current, what is potential difference, will be uploaded to my channel shortly. So by then, at this time, we shall discuss about combination of resistors.
Combination of resistors.
If two or more than two resistors are taken into account, then we get one equivalent resistance. And that how to find that equivalent resistance, how to evaluate that equivalent resistance, you shall learn today. Say n number of resistors are connected in series. Series means I am telling you A and B are the 2 points in the given circuit. These 2 points are connected to a battery, a combination of cell. The battery have a EMF E and an internal resistance R. Upon correcting all these resistances, we calculate the amount of current that will flow through the circuit by using the given equation. I equals EMF by R plus R. This is the equation for Ohm's law. EMF is given to you, the total resistance R is given to you, and the internal resistance of the self, which we will again discuss in the next video, is also given to you. But what is the capital R? What is this R? We say that this R is the resistance of this circuit. But mind it, there are many resistors in this circuit. So how will you how will you evaluate the total resistance? These 1, 2, 3, 4, such n number of resistors are connected in series. Series means a same constant current flows through these resistors. The resistance of the first resistor is R1, R2, R3, R4, and simultaneously it is Rn. So in this part, from here to here and from here to here, there are no such resistance. It means the potential difference, if we calculate the potential difference between this point and this point, it is zero. Actually, it is a fact. In a given circuit where you have many such resistors, the total potential difference, rather you say the terminal voltage of the battery. Terminal voltage means EMF equals IR plus IR. This is the load lost volt or the drop voltage. Drop voltage of the battery. This resistance R is constant for a battery, and it depends on the electrolytes, the concentration of ions and all. This EMF is also constant for a given battery, but this amount of current, it will vary, and the amount of current that the battery will send, that the circuit will draw from the battery, will depend on this capital R, the equivalent resistance of all these resistors. So each individual resistor is having a resistance R1, R2, R3, etc. Okay. So between the points A and B, the total potential difference is IR, and say IR is V. This V is known as the terminal voltage.
Okay.
Okay?
Yeah.
Do you have any questions?
No.
Okay. So this is known as the terminal voltage, capital V. And between this terminal A and B, you have this voltage, because here you don't have any resistance. See, V equals IR. If resistance is 0, then voltage will also be 0. Potential difference will be 0. So here the potential difference is V.
I take some point that actually the resistors, VA, VB, VC, VD, and ultimately VN. Okay. VB, you have VD and it goes to VN. VN minus 1.
Since these resistors are connected in series, See, connection in series means a constant current flows through all these resistors. Same current I flows through all these resistors, but the potential difference between these resistors is different. Here the potential difference is VA minus VB, here it is VB minus VC, here it is VC minus VD, here it is VD minus VE, and here it is VN minus 1 minus VN. So actually, since it is connected to the positive terminal, so it will be having positive potential, negative potential, higher potential, lower potential. So we can write that the total voltage, the total potential V is equals VA minus VB plus VB minus VC plus VC minus VD plus VD minus VE plus up to VN minus 1 minus VN.
Yes.
So summing up all the potential difference between the resistors, we can get what is the total potential difference across the combination of resistors in series. So VA minus VR. By applying Ohm's law, we know that V, the voltage, the potential difference is directly proportional to I, the current. So V equals Ri, where R is the constant proportionality.
Yeah.
So VA minus VB is I R1 plus I R2 plus I R3 plus I R4 plus up to I Rn. And if you take I common, this. But what is our objective? What is our primary goal? Our goal is to find the total resistance. Our goal is to find the equivalent resistance. And the equivalent resistance will be the total voltage is V by I will be the equivalent resistance. And okay, and you know that the equivalent resistance will be represented by RS is equals V by I. And what is V? We have got that V is this. So it is VI summation of resistors where I is 1 to N
By I.
by the amount of current that is flowing. So I will cancel. So we say that it is the summation of the resistances that are connected in series. So the total equivalent resistance is R1 plus R2 plus R3 plus R4 plus up to Rn. This is the equivalent resistance for a combination of resistors that are connected in series. This equivalent resistance, the concept is that if you replace all these resistors by a single resistance, then in order to keeping all other factors constant, if you replace all this n number of resistors by a single resistor, then this will be the resistance. This RS will be the resistance. This is about combination of resistors in series. Mind it, series. You must remember that through series, the voltage, total voltage is V, okay? But the voltage of the respective resistors is different. But the amount of current that is flowing is constant. Derivation of the equation for combination of resistors to find the equivalent resistance when the resistors are connected in parallel. So this is a
Point A. It's really interesting to draw this kind of design which represents resistance in circuits.
So, conventional current flows from the positive terminal to the negative terminal, you know this. So, a current of magnitude say I will flow. Obviously, the amount of current that will flow, that is not fixed. But the amount of current that the battery you will give to the circuit, or the amount of current that the circuit will draw from the battery, it will be given by the EMF of the battery by R plus R. the internal resistance is small r. But what again is this capital R? This capital R is the equivalent resistance of the circuit. Now, if you see that this is a purely parallel combination resistance, having resistances R1, R2, R3, R4, up to Rn. Okay, so the current is coming. Now, the current, imagine yourself to be a current and you have several forks in the road. You will not insult any road, I suppose, and you will go through each of those roads, and therefore the current also divides partly. The current also parts, and the current parts like this: I1, I2, I3, I4, up to IN.
Yes.
And I equals I1 plus I2 plus I3 plus up to IN. All this current come here: I1, I2, I3, I4, IN, and they again becomes I, and they return to the battery, completing the circuit.
Oh.
So, what is parallel combination? What is the characteristic of parallel combination? You see that all the endpoints of the resistors, they are connected to a single point, A and B. It means the potential difference of all the resistors is V, and V in this case is the terminal voltage of the battery. R we shall find right now. So the potential difference of all the resistors will be same, but the amount of current that is passing through each of the resistors is different.
It's different.
So the case is actually opposite to that of the series combination. In series combination, the amount of current that is passing, that is constant. The potential difference being different for the resistors.
Yeah.
But in this case, the potential difference is same. The amount of current differs. The amount of current differs. So let us find the equivalent resistance in this case. If you agree to me that the voltage is same, then I1 R1 equals I2 R2 equals I3 R3 equals I4 R4 equals up to IN Rn.
Correct?
According to Ohm's law,
Acha.
V equals IR. V is same, so their product will also. Okay, so the amount of current that is flowing, I equals I1 plus I2 plus I3 plus I4 plus up to IN. Now I1 is V by R1 plus V by R2. Am I okay, Papa?
Yeah.
V by R3 plus V by R4 plus up to V by RA. Well, because of Ohm's law. Because of Ohm's law. So if I take V common, this I. This I. Now, what is this I? If I say that the equivalent resistance, equivalent resistance means if I replace all this n number of resistors by a single resistance between the points A and B, then what will be the resistance of the resistor to maintain this fixed, this current, this EMF, this internal resistance? So what will be the resistance of that resistor to replace all this n number of resistors? And that resistance is given by RS. So I can write that V equals I RS. So it is V by I. Sorry. I V by RS. V by RS.
Easy cancel.
So 1 by RS will be 1 by R1 plus 1 by R2 plus 1 by R3 plus up to 1 by Rn. Means when n number of resistors are connected in parallel, then the reciprocal of their equivalent resistance is equal to the sum of the reciprocals of their respective resistances.
Okay.
Okay. So the current I will flow, and that current is given by EMF by R plus R, where R is actually R1 R2 by R1 plus R2, because you know we have to calculate the equivalent resistance, and that equivalent resistance is 1 by R1 plus 1 by R2. Okay, this thing. Now this current is going and this current is parting I1, I2. If it is given to you that there are only two such resistors, then how can you find the ratio in which the current will get divided? And it is a fact that the current will get divided in a ratio R2 is to R1. Again I repeat, if two such resistors are there, then the current will get divided in the resistor. I2 is to R1 means I1 is to I2 equals R2 is to R1. So if you want to find out the value of I1, then it is actually R2 by R1 plus R2 times the total current.
Yes.
And I2 will be the total current. Okay, R1 by R1 plus R2 times the total current. In this way you can find the amount of current that is passing through each of the resistors. These currents will come here and again it will complete the circuit.
Yes.
So this is a discussion on combination of resistors in parallel. If it is a parallel combination, then the equivalent resistance 1 by Rs will be equals to 1 by R1 plus 1 by R2 plus there are n number of resistors Rn. So, and it is given to you that R1 is less than R2 less than R3 less than dot up to less than Rn, means R1 is the least resistor. So mathematically we can write and this 1 by Rs minus 1 by R1, you see that this entire thing is positive.
Of course.
Because no resistance can be negative.
Of course.
Each and every resistance is positive. So this entire thing is positive. So it is proof that since 1 by Rs is greater than 1 by R1, so Rs will be less than R1. Okay?
Yes.
So this, in this parallel combination, the equivalent resistance is even less than the least resistance in the combination. Okay, so that's all for today. Wish you a nice day. Please like and please subscribe my channel, and I will present you awesome contents every day.